semicolon here, okay? So there's semicolon here. Okay, now, so what we want to find out is the name of the students and the GPA who applied for admission into computer science to Old Westbury. I'm going to assume that Old Westbury data we have, okay? And they were admitted, okay? They were admitted, okay? And also we want to say these students who are coming from high school size less than 1,000, okay? So it's very simple. We could just use this here. What do we want in the answer? Select clause says this is what we want. We want student name and we want GPA, okay? So where the student name will come from? Not in apply. Student name is in student, okay? GPA is in student, all right. And they are all unique. Student name is only occurs in student and GPA only occurs in student. Therefore, there is no ambiguity, okay? So we're using student and apply. These are going to be cross product. And what we have to make sure is we have to filter them. So what we have to say, the student applied for it. So therefore we say student.sid equal to apply.sid. We only considering those students who applied, okay? And they come from a high school size 1,000 and major they applied is CS and they applied to Old Westbury and they were admitted, okay? Now, one more thing I want to point out. I have ands here. This is equal to this and. I have no parentheses. You don't need any parentheses because we can go from left to right. We match this and then we have to see if the high school size is 1,000. If it fails, you go to the next tuple, then the next and the next and the next and the next, okay? So you don't need any. If all of them are and, you don't need any parentheses. If all of them are or, you need no parentheses. But if they are mixed, then you got to worry about it. Okay, so this is one way of saying where we have a cross product, and then we have to say how do we filter it. Or let's say we are not going to use cross product now. We are going to use the new definition of inner join. As I told you before, you can use inner join with on keyword, and it works like just like this. Okay, cross product, but you have to say student SID equal to apply SID. Okay, and then all this stuff here you can put right here. Now, why there's no where? Well, you can put all the conditions with on and you don't need where. Is everybody listening? Hey guys, you listening?
Yes.
Okay.
Yes, okay.
Okay. Did you understand what I just said? You don't need any where with on. You can put all the conditions in on. So we're saying here, select student name GPA from student join, inner join. You remember, anytime you want to say inner join, you can just say join because that's default is inner join. So inner join student and apply on student SID equal to apply SID and all this stuff. Okay, that's another way of saying. There's another way of saying, do the natural join, then you don't have to put this condition. Okay, so what do we say here? Select student S name and GPA from student, natural join apply. Now, anything common between student and apply, they will be joined on. How many things are common between student and apply? Only one thing, SID. So that is it. And then you have to use the where condition again, because we can't use on here now. We have to use the where condition. Size of the high school is less than 1,000. Major is this. And C name is Old Westbury. And then, of course, if you want to say decision equal to yes, you put that here. Okay? Any questions so far? Right here. Any question? Right here. Just right here. Any question? If no, there's another way of saying it, because this is dangerous, as I told you before. This is not a software engineering point of view, because there could be many attributes in student many in apply, and there could be plenty of them common, and we didn't mean to join on them. We used to join only in SID, so we got screwed up. Okay, so how do you do this then? Well, instead of doing natural join, you're going to do something similar to natural join. Student join, apply using SID. Now you are telling that you can combine them, something like natural join, but only on one attribute which I mentioned here. If I want more attributes, I can write them here with commas. Any question? Okay, if there's no question, there's one other thing which is no. Okay, this is the no. Right here I wrote down. What is a no? If I use using, I can't use on. I will have to use where. If I say from student, join, apply this, then I have to put all this stuff here. I have to say where condition, not on. On and using cannot be mixed. Okay? Any question? This guy, come on. This guy and this guy, they cannot be mixed. Okay. All right. Now, let's look at this problem. Here we want students who apply to some college. We want the student SID. We want student name. We want college name they apply to. And we want also enrollment of the college they apply to. Now, if you remember, student has, what does student has in it? Student ID, student name, GPA, and high school size. What does college have? College name, enrollment, and state. And what does apply has? It has SID, college name, major, and decision. Okay, so since we need everything, we need the name of the college, which will come from apply, which is okay. We need student ID, which can come from SID, but the student name is going to come from where? Where the student name is going to come from? Everybody is sleeping?
From student.
From the
Yes.
student level.
That's the only place the student name is there. Why it says here apply.sid? Why doesn't it say SID from student? First of all, you have to say where the SID is coming from. Why? But it occurs two places, in student and in apply. You will get an error if you simply say SID because it's ambiguous. It's two different places. So why I say apply SID? Because I need only those students' ID who applied. And then I need those people's name who applied. What about here? Why don't I get college name from the college? Again, if people didn't apply to their college, we don't want that college name. We want the people who are in the apply. Those colleges' names whom the students apply to. And of course, enrollment can come only from the college. And we don't have to qualify this. All right. So all this stuff comes from apply, student, and college. Now we have to, this is like a cross product. Multiply this with this and the result with this, and then you have to filter it. Okay. So we can say here filter, where two conditions you have to say. Remember, student dot SID equal to what? Who's going to tell me? Student dot SID equal to what?
apply.sid.
Thank you, thank you. Okay, I gotta keep on going. And what do I say? I have combined student and apply. Now I have to combine the apply and college. So what do I say? College dot what? What is it? College dot sad. What is college dot? How the college and apply can be combined? How? What is the common thing between college and apply? Come on, guys.
You say CNAME?
That is right. Equal to apply dot CNAME. Okay? Okay, so what we did essentially here, implicit joins. We could did the cross product of this with this with this, and then put these conditions, then filter it out. Okay, why did I write this heck for? What for? Well, I just wanted to give you a, over here, I just want to show you something, that this thing here, I can replace it with something, and I'm going to show you and see if you like it. I'm going to say from, I'm going to say apply, apply, join, student, join, college. Okay, this is not good. That's all I want to tell you. This is not good. You can't put from here, say, apply, join this and this. Okay, because we don't know whether we are joining these two first and then joining this, or what the heck is going on. Left to right, right to left, middle to what, you know, do this, go there. Okay, so this is not allowed. This is incorrect. It will not be accepted. So if we want to do this, we will have to put a parenthesis. Okay, so we can say, let's say, I'm just going to try to do it short. So let me get that color here. So I'm going to say from okay. I will write this way. Okay. Apply, join, student. I'm going to say, I'm going to do from left to right. Student. And I'm going to use using. So what should I say? Using what? Come on, guys. Who's going to tell me? Apply, join, student. Using what? Come on. Okay, Sarah. What's going on? What's common between apply and student? Okay. Thank you. Thank you, Victor. Okay. Let's go on here. So I got SID. Put it in parentheses. And then what I have to do, I just put this whole thing in parentheses. So I didn't do it right. I had to start here with the parentheses and then go over here and put the parentheses. Now, after I have done this, I can say join. Now what I need to join? College, right? College. Again use using. Using. What is it? What I'm using here now? Come on, guys, fast. What I'm using? How are they being combined with college?
CNAME.
CNAME. See, when you write the code, you got to know this. So it's not like a query language you think that, oh, give me this, give me this. It's not that. You need to know where the answer is going to come from and how the things are going to be combined. So this is just the whole statement here. You see, this whole thing here where we said, and the from, we said apply student college and where student SID equals this and college this, and we just put it over here. We said, oh, those were two different things. So let me write, put it line here saying that this is wrong, right? Remember? That's what we said. Okay. So the correct way of saying is apply join student using SID. You could say natural join, but we don't like that. So put it in parentheses. Once that is done, then you can join with college using this. The reason for this is, first of all, the efficiency of this query is going to depend upon how the joins are carried out. Okay? So this kind of join business where there are many joins, people use this, the database administrators, to tune their system to find out how good the system is doing these queries. Okay? So I just wanted to show you that this is not allowed. And then remember now, if we have more conditions here or something, we can't use on because we are using. Remember that. We have to use where. If I want any more conditions here, oh my God, this should be capital, remember? Okay. I want all the keywords capital. So if I have any more conditions, I have to use where. I cannot use on because we just said this here. On and using don't go together. Okay? Any question? I don't have too much time to go over this, but I just wanted to show you that this is good. Okay? All right. I want to show you something else before I go to. So let me show you. Okay. Here. So let me show you something else. Okay. So let's say we want to find, oh, come on, here. I want pair of students who have the same GPA. Pair of students who have the same GPA. Okay. Now, what do you think? How many relations you need? We have three relations: student and college and apply. Where the answer is going to come from? Fast, guys.
Student.
Only from student. So we have to imagine that we have two tables of students and we are comparing one with the other. Okay, so we pick the first person on the time, I think it's Sally or somebody, and you go to the other table, top to bottom, see who else has the same GPA as Sally. Okay, and then you got a pair. Then the next one, the next one, the next one, the next one. You keep on doing that. So you're going to use this twice. Okay, you do this many times. Supposing I tell you, one-way flights, a table of one-way flights from all the cities from our, USA to other cities in USA or anywhere else. And I want to find round-trip flights. Well, I have to use the same table twice. Once going one way, then coming back the other way. Okay? So many, many times you will be using same tables twice. Okay? So here, what we are looking for is, we want to select. Okay, we want to select a student and the name. So let's call this student 1. Okay, So from this, we will select, I'll show you in a minute. Okay, let me show you here. Okay, so what you are really doing is we are saying from student, call this student S1. You don't have to use the word as, and same student. Now we give it another name, S2. You have to leave some blank in between, okay? All right. So I have same table of the student, S1 and S2. So I pick somebody from S1 with certain GPA, let's say here. So SID, comma, S1's GPA, dot GPA. Then I will go to the same table again, and I say S2. I pick another student, and I want her GPA S2 dot GPA. Okay. Now let me ask you one question. You want this SID and this SID the same? We want this GPA equal to this GPA, right? Yes. We want this GPA equal to this GPA, right?
Yeah.
What about the SID?
No.
Of course not. Then you will be comparing the student to itself or herself. Come on. You don't want these to be the same. They should not be the same, and these should be the same. Okay? So what do we do? What do we say here? Number one, we have to say the GPA must be the same, right? We want the same GPA. Student 1 dot GPA equal to what? Student 2 dot GPA. Yeah. And I don't want these to be equal, right? So I could say and what? S1 what?
Dot SID does not equal S2 SID.
Dot SID not equal to what?
S2 dot SID.
Okay. Now, actually, it's not going to work anyway. Let me write it anyway. Yeah. Okay. I don't know if you have the table in your hand. So if you look at the same table, okay, all right. First of all, if we say they are not equal, then Sally will not be compared to itself, right?
Yeah.
Where is that sheet? You should have that sheet. You guys have that sheet?
I have it.
No? Where is my sheet? In any case, if you look at the sheet, it will be more clear. Oh, here it is. Okay, so if you look at student and you look at Amy, it has 3.9. Okay, so we are not comparing Amy with Amy in the two tables. We can compare Amy, then there is Doris has 3.92. So we can say we will compare Amy with Doris, right? Is that good?
Yeah, that's good.
Okay. Well, it's not good. Because in one table, when we go, start from Amy, right? And the other table, we don't compare with Amy, but we compare with Doris. But now in the first table down below, there is Doris also. Now what do? We go to the second table, we compare with Amy, 3.9. So instead of having Amy, Doris, now we have Doris, Amy. Do we want that? No. You don't want that. You have to get rid of that. So what you're really going to say is that SID dot S1 dot SID not equal to is not going to work. So we can just use less than, and that will work. That's it. Okay, everybody understands? Just take the table and look at it, because you have Amy with Doris, then you will have Doris with Amy, because you see what's going to happen is there are two tables. One is S1, one is S2. So if here on the top is Amy, but further down is Doris, over here top is Amy, further down is Abyss. So Amy with Amy will not be compared, but it will be compared with Doris. So we got Amy, Doris, and then you go further down, you have Doris, will be compared with Amy on the top, but the Doris and Doris will not be compared. So we can't do that. So therefore, you have to say SID, S1 dot SID less than S2 dot SID. Remember this. Okay, take a picture of this if you want. All right. This is very important. Okay. All right. I want to show you something else. There's so much to show. Oh, by the way, what happens if I just say this? So, okay, draw a line here. Okay, let's say I say select everything from the student. Everything, where is star from student? Okay, I can say that. The only problem is I'm going to get the same thing, but the order of the columns, it may change the order of the columns, okay? Now, what about if I say something like this? Select star from, let's say, student, and I'm going to do, let me say, I'm going to get student used twice. And then I'm going to do natural join student S2. What is going to happen? What do you think is going to happen in this case? Right here. What? Remember natural join, when you join two tables, they are joined on all common attributes. Yes? And they are not repeated. That's right, Kevin. Nothing's going to happen. It's going to be the original relation. Remember this. This might show up on your exam, something like that. Don't be confused. This is really straightforward. The definition of natural join is you join one table with the other table on all common attributes, and the common attributes are not repeated in the result. Okay, guys? This closes the story right here. Now, I'm going to show you something else which has to do with, okay. Supposing I want to get all students who applied, okay, let's get all students who applied to some college and those who did not apply. Okay, right. The people who applied, we can get them by doing this natural join, okay, or using something. So we can say here, don't like that. Okay, I can say here select. So I want the name of the students, right? And I want their, let's say I want their SID also. SID, and I want student name, okay? And I want, let's say C name and major, okay? That they apply to some college. And what major they apply to. Okay, so I'm going to get it from student and apply, right? That's what it's going to be. So, yes. Okay, so let me do that. I don't know if you remember this or not. Let's see, student. I'm going to use something called left outer join, and I'm going to explain to you. Okay. So that left outer join, let's say apply, then I'm going to use the word using again. Using, what's the common between apply and student? What's common? SI. Thank you. Okay. So what do I did here? What did I do? Okay. Now let's just imagine for a second. I said student ID, student name, C name, and said student join. Forget about left outer join first. Let me say that here. Let's just put this in a little box. Okay, so what I did here is student join apply using SID, which is just like a natural join, as I told you before. It's like a natural join. Of course, here I should have put semicolon anyway. Okay, all right. So that will only give me those students who apply. So I will get for them the student ID, S name, C name, and major. Now, something is wrong with this statement. I told you before. SID occurs in how many places?
2 places.
2 places. Okay. Now, remember in this case, we are going to get, if I don't have left outer, I have to say here, student.sid. Okay? But if I say left outer join, what that means is I not only get all the people who applied and all the people who did not apply, which has what? Student ID, student name, and there will be null, 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 because they didn't apply to any major or college. So I will get all the people who applied and all the people who did not apply from left. From the left means student ID, student name, college name will be null, major will be null. Okay? That's what left or join means. I could have done another way too. I could find the people who applied, then find people who did not apply, then I can do the union. Right? I could do that too. Okay, I can do that too. I could get the students who applied and who didn't apply. So should you want me to write it like that? Let me write it down for the heck of it right now. Okay, so I could write it. Okay, so I'll write it right here. So I will get all these things. So I'll get here, select student dot SID, S name, comma, C name, comma, major, right? Then what I have to say, from where? I could write the same line here. Can I do that? So that, would you get confused? It is correct, but it should not be done. From, what are we going to get from? I'm getting from student. I'm getting from student. Can I say natural join? Natural join, apply. And this finished, this sentence finished. Then I'm going to union with the students who did not apply anywhere. Okay, so let me show you how I'm going to write that. So I'm going to say select. Yeah. I've got to go to the next line. Select. Okay, so I'm going to select student ID, and I'm going to select student name. If they didn't apply to any college, it will be no. They didn't apply to any major, that will be no. Okay, and then I'm keep on saying that, oh boy, from student. Okay, I'm going to get it from student where these guys did not apply to anywhere. I'm going to explain this to you. SID not in where students applied somewhere. Select SID. Okay, from apply. Come on. Okay. Since I did something here, which I want to show it to you. Come on. Okay. All right. So I just have to make sure my syntax is correct. Oh, parenthesis is correct. Parenthesis. I have to go over here. Okay, select SID. From, okay. All right, let me explain this to you guys because we haven't done this. Okay, here. Just look at this part of the, okay. So what I have here, select SID. Oh, this should be dot here. So make that dot. Okay. Okay. So this is SID dot S name. And then, oh no, wait a minute. It's not dot, it's comma. Jesus. It's comma. Okay. All right. So we want SID, we want S name. These people never apply anywhere, so they all come from student ID, student name. Null, null, they didn't apply. From student, we want those students who didn't apply anywhere. These are the students who applied. Select SID from applied. So these are all the people's SID who applied. But we want those whose SID is not in here. Okay, now let me just tell you something. What I wrote here is called a subclass. This thing over here is called a subclass. Let me write it up here. It's called the subclass. Okay, it's called a subclass. This thing right here, from here to here. Okay, so it is a select class, is a complete select thing, because select statement says what? Select something from something. And there may be a condition, but we don't need a condition here. So this is a well-defined select SQL statement. So that's why it's a class in itself. But we want to look for those students who didn't apply. That means their SID is not in here. Those are the ones we want. So from student, we want those students whose SID is not in here. If we want to get students who applied, I could say SID in here, but I want not, therefore not in here. And then the student who didn't apply, when I want to look at them, output, I would like to have their SID, S name, and then of course it will be null and null because they didn't apply to any college, they didn't apply to any major. Any question here? So this is another way of doing it. You find the students who applied, find the students who didn't apply, you can do the union. Okay, now let me ask you one more question. Somebody has to answer this. What is the answer to this relation, this SQL class, and what's the answer to this SQL class in terms of their scheme? What is the answer? What's the scheme of this relation and what's the scheme of this relation? Come on, guys. Let me see who's here. All right. James Chong. You there? Okay. Tell me, what is the scheme here and what is the scheme here? Okay.
Can you repeat the question? Huh?
Scheme. What is the scheme of the answer here? And what's the scheme of the answer here? Okay. Let's see here. Who else is there going to answer? Oh, Beyonce. Can you answer it?
Is it S? Oh.
What is the scheme here? And what's the scheme here? How do I find out what's the scheme? Leela, how about you? How do I look at this SQL statement and tell what's the scheme? I could ask you the answer question because the answer to all SQL statements is a relation, whether it's an empty relation, whether it's a relation with single attribute, or 2 attributes, 3 attributes, 10 attributes. Okay, Robert. Where are you hiding, Robert? I don't see you here.
I'm here.
Okay. Oh, there I see you. Okay. Hey, guys, Robert, this is the obvious answer. He said, look at the select class up on the top. What is the answer we are asking? S name and GPA. So those are the two attributes in the relation. That's the scheme right here. What is the scheme? SID, S name, C name, and major. Okay, what's the scheme here? But the scheme in this case, in the second relation, Sarah is now speaking up.
I just wanted to ask, like, since it's null and null, so would we put up the same scheme since we have to put in as null? So is it going to be?
That's why you have to put up null.
Okay. All right.
To make the scheme same. Otherwise, you cannot union. Apple goes into apples.
True.
Oranges goes into oranges. You can't put a basket of apples into basket of oranges.
Right.
Remember that if you do union, if you do intersect, if you do difference, they must have the same scheme.
Got it.
Whether it's a relational algebra or SQL, does not matter.
Okay.
Okay, so let me remind you, we do left outer join. What about if we did right outer join? What happens then? Then what happens is, if you have right outer join, what will happen? Right outer join.
Do we start from right to left then?
That's correct. When you combine student right outer join with apply, whatever in the apply didn't match with the student, that will be put back here in the right. If we have full outer join, then the join itself, which is the natural join, plus the left, which we didn't go match with anything in the right, and the right, which we didn't match from the left. So I'm going to give you an example. Take a copy of this, guys, quickly. I have to give you one example. And then I got to move on to something else. Okay? All right. All right. Okay, erase it. Guys, I don't hear anything.
I'm good.
You are good, I know. What about the others? You want to take a picture? Take it.
Everything's good.
All right, guys. Okay, hair gone. Okay. This is the finale of the joins. Okay. So let me show you. Very simple example. Something shows up like this. Don't get flustered. We have three relations. Okay. Each one of them. Okay. Over here, T1, what happened? This became blue. No, okay. T1 has A and B, and T2 has, oh, wait a minute. T2 has B and C, and T3 has, what does T3 has? A and C, okay. Okay, now I'm also going to give you data. A, B, B, C, A, C. Okay, now start here. This is just one. Oh, come on. Come on, 2. Next one, let's just make it 2, 3, 4, 5. What the heck? And 2, 3, let's see, 4, 5. That's the data. Okay, that's it. No more data. Okay, here is what I'm doing, and let's see if you can figure it out. Select A, comma B, comma C, and from parentheses open, I'm just going to write it down, natural full outer join T2. Let me do with T2 first. Then I'm going to do the natural full outer join with T3. Okay. Now I'm going to do, actually I could write all here, but I'm just going to write it down here. Okay. So I'm just going to do, I don't need parentheses anymore. I already have parentheses. Natural, oh yeah. Natural full join. I'm doing natural, remember that, okay? So I could have written with using, but I don't want to do that because that makes me do more work. Okay, this is it. Finished. Okay, so the answer is, oh my God, time runs so fast. Can't we stop time, guys? Hey, Sarah, what are you doing? Why you are running the clock so fast?
Am I?
Too fast you are running. Okay, let's I'm going to explain something to you guys. One of the things you must understand, natural join. If I take this and natural join with this, it will combine on all common things. All common things. What are the common things in between these two? Come on, guys.
B.
What are the common attributes?
B.
B.
They. Okay. So B is 2 here and 2 here. Therefore, when I pick this up and try to join with this thing works. And what do I get in the answer? Come on. What do I get in the answer? In the output?
A, B, and C.
I got A, B, and C. What is the output? Those are the names. What do I get?
1, 2, and 3.
1, 2, and 3. That's not so hard. Since it's a natural join, I don't write B table twice. It's only once. So if I do natural join of this with this, I got this. Okay. Now, if I want left outer join, what do I have to do? Is there anything from the left which did not combine with the right? Is there anything? Is there any tuple in here in T1 which did not combine with some tuple in T2? Michael Young. Sahil.
No.
No, there isn't any other tuple. Can you see it? One here, one here, one here. So the left outer join doesn't give anything extra. Okay, what about the right outer join? Is there any tuple here which didn't combine with some tuple here? Which one? Which is that one? No, stop it. Okay. Now it's not your turn. It's Saad's turn. Hey, Saad, what's going on? Are you sleeping? Come on. Are you here? Say something. You have got a voice. Why our audio is not working? Come on. Now, is there anything on the right-hand side here which did not combine with the left-hand side? Because remember, the full outer join first does the natural join, then anything which didn't combine from the left with the right puts that in the answer. Anything which didn't join from the right to the left, put that in the answer. Okay, let me ask you this. Okay, now I explained this already to you. First we do natural join of this with this. Okay, no, there is nothing. First we do this with this. When we do the natural join, B is common, this is 2, this is 2. Okay, so therefore we get 1, 2, 3. 1, 2, 3. Now, there's only one tuple here which combined with this. Therefore, it doesn't give us any other thing from the left outer join. There's only one tuple here. Just keep quiet right now. Okay, guys? Okay, just listen. Okay, so from this side, there's no tuple here which we didn't combine with this. There was only one tuple, it combined. And that's what we got. Okay? So therefore, the full outer join of T1 with T2 is this. Now, hold your horses. I am just have a lot of people getting upset. They think that you cannot join one relation with the other if they don't have the same attributes. That's nonsense. Why would you want to join them then? We are joining student with a boy.
The confusion is in your from statement, you outer joined T2 with T3.
What's one? We are first.
In your join statement, it says full outer join T2 with full outer join T3.
Oh boy, what the heck? Thank you. Where were we sleeping before? All of us here. Let's. Oh, yeah. How did we do this? Okay, it's not going to work, but I'm going to squeeze it in. Okay. Thank you. All right. So what we have here is we want to join T1 with T2 like I was saying here. So if we look at this statement, that should have corresponded to that. So it should be T1 natural full outer join T2. Now, is this okay?
Yes.
And whatever answer we got, we want to do natural full outer join T3. Yes, go ahead. Go ahead. Okay, so this is okay because we are just, I was saying it, but I didn't miss this here. T1, T2, natural full outer join with T2. Okay, that's what we have. Now we want to, whatever the result we have, we want to join with T3. Okay, this is T3. Okay, guys, this is T3. Okay, so what we are doing is joining this T3. Maybe we should write it right here. Okay, we have T3. You can write it right here. We have T3 parenthesis A, comma, C, and the data is A, C, and data is 4, 5, okay? 4, 5. Okay. Now let's look at the same thing. First, we need to know when we join these things, what will be in the answer? Well, the answer will be all the common attributes. What do they happen to be? A, B, C, plus all the other attributes. Okay. So here the common attributes are A and C, and the other left attribute is B. So all the attributes except common attributes are not going to be repeated. So what is in the answer? Again, A, B, C. Okay. Now, first question is first, okay? Don't worry about outer join. Let me do natural join first. Natural join. That's it. Let's do this answer, whatever this answer is, with this relation. Let's do natural join. What will be the answer if we do natural join? Okay, what's the definition of the natural join? You need to know that. If you don't know that, you would be wrong.
It joins all the attributes.
Common attribute.
What does that mean? Join all the common attributes. What was the first statement when I told you what is a natural join? First statement is what? There are three conditions. What are the first condition? It is a what? Is what?
Equijoin.
That's right. Thank you. Thank you. And what's the second condition?
Second condition is joins on all common domains.
That's
common
right.
domains are
And
not
what's the
repeated.
third condition?
Common
Joined
domains
or
are not
joined?
repeated.
Thank you. Oh boy. Okay. Now, a lot of you are going to slip on this. Now, I want to join this natural join with this. What are the common attributes? A and C. Yes?
Yes.
What's the value of A here?
1,
Over here, C value.
3,
What's the value of A here?
4.
Does it match? Does it match with over here?
No, it
No, it
doesn't.
doesn't match.
And does the C matches?
No.
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 So do we get anything in the natural join? Do we get anything in the natural join? Come on, guys.
No.
No. Okay, let me ask you this. Supposing this was 1. Okay? If this is 1. Okay, Syed, we are looking from you to some answer. If this was 1, then what will be the output in ABC here for the natural join? Just write it on here, 1, 2, 3. What will it be? What will be the output in ABC? If this is 1. All right, very smart. Very smart. Anybody else? Very smart means too smart. Okay. Hey guys, can you read this here? What is written here? This over here? Read it.
Yeah.
Read what it says here. Read. And then answer this question. Who's going to answer this? Scott Schwartz, Siddiqui, Zayed. Ha. Now keep quiet, okay? Okay. All right. Okay, guys. All right. Who else is here? What is my friend here? Zurin. What happened to him? All right. How about the Aditya? Aditya, what's going on? What should be the answer here, Aditya? Alexander. Arbinson. Eric. What's the answer, Eric? Okay. All right, guys. So we have ABC, and here we have AC, and A and C are common, and it says right here, it's an equijoin on all common attributes. All common attributes. This is 1, this is 1, but this is 3, and this is 5. They are not equal. The answer is nothing. Okay? If you match 1, it doesn't work. Equijoin on all common attributes. Okay? Now, we want to do full outer join. So first we want to do left outer join. What was on the left which didn't match with the right? What was on the left? What was on the left which didn't match with the right?
C.
C.
What? What?
3.
No.
Okay,
When
say it
we
again.
talk about what did not match, we are talking about the tuples.
Okay, so 3 didn't match with 5.
Doesn't matter 3 didn't match. It's a question of tuple. Which tuple didn't participate? No, B is not a tuple.
No, it's 1, 2, 3, and 4.
No, C is not a tuple, Danielle. It's the whole thing, the tuple. 1, 2, 3. That is the tuple. Did not participate in any match. The tuples on this side. Okay. Now, what are the tuples which didn't match from this side with this side?
4, 5.
Okay. Now, 5. 5 is not a tuple. Okay. Okay. So that's 4. And then there's nothing and B. So that should be null. And over here is what? 5. So we got here when we try to, okay, first we did a natural T1 natural outer join with T2. We just got this. Then we tried to do natural outer join with T3. With the natural join, we got nothing. But with the left outer join, we got 1, 2, 3 here. And with the right outer join, this didn't match with anything. So it's 4 and 5. And then, of course, B is null. Now, what about if we change these things? What about if we did something like this? Here, let me get a different color. Okay. What about if I took T2 right here and I did natural outer join with this. So I'm going to do that. Then I don't really need parentheses here, so I'll take it out. Okay. So instead of joining T1 with T2 and then T3, I want to join T2 with T3. Okay. So let's do these guys over here, natural full outer join. Okay. So what do we get? What will be the answer be first? What will be the output? Output will still be what? What will be that? Still, the schema will be A. What else? What are all the attributes? B and C. Okay, so let's do the natural outer join with these two first. Okay. Okay. Sorry, not natural outer join, natural join. So we have T2 natural join with T3 right here, this and this. What do we get? Natural join this with this. What do we get? Guys, what do we get?
You get nothing.
Right here, just read the definition. C is common between the two and is the value of, pick up the first tuple, look at the C value, pick up the first tuple here, look at the C value, this is 3, this is 5, no match. There are no other tuples, fini. So there's nothing. Okay, now if we want the left outer natural, full, then what do we have? Well, on this side, this guy didn't match. So therefore, this will be just null. And the next one will be what? Two, right? And the next one will be 3. So that's the left. What about the right? Right, this guy didn't match with anything. So A will be 4. A will be 4, right?
Yes, and B would be no, and C would be
B
5,
will be now
and C is 5.
5. Okay. Now what we want to do is forget this thing here. This guy is here. Now we want to look at this guy and this guy. And this is being done from the left. T1 with this, okay, is done from the left. This with this. Okay, so what are the common attributes? Well, common attributes is B only and A and B, but all the attributes are A, B, C. So the answer is still going to be, schema is going to be A, B, and C. Okay, so first let's do the regular join, natural join. So take AB and take this. Okay, so what do you see here? What is common here? A and B, and between this here, what's common? A and B? Between these two, AB is common. Okay, let's pick up this tuple. It has 1 and 2 value. Well, what's the value here?
Null and 2.
Does that match?
No.
Nothing. Okay, let's pick it up, match with the second one. Well, A is 4. Does it match?
No.
B is no. We got nothing. When we do the natural join of this with this guy over here, we got nothing. Well, what didn't match from this side? Well, 1 and 2. So 1 here and 2 here. And the last one will be null, right? Now what? From this side, what didn't match? Did this match with anything here? Did it match with anything? Did anything from this relation match with this? Come on, guys. Did anything match? Okay, you guys are not going to answer. Nothing
Professor,
matched.
which relation?
It's
Oh,
right
no.
here. This is all right here. Okay, so the left
No.
outer join says, did anything from here matched with this? No.
No.
Therefore, this is the one which is didn't match. Now, right outer join says, did anything here didn't match with this? Well, it's the whole thing. So this whole thing will be here. Nothing else. Right here. It will be null 2, 3. Oh, yeah. Come on. Null 2, 3. And the last one is 4. And now five. All right. So the answer of this blue thing once we did was right here, and the previous one was this. The previous one was here, sorry, right here. So that's the first answer right here. T1 with T2 and then T3. That's this answer. Here, T2 with T2 with T3, then T1 on the left. This is the answer. Okay? All right. I got 10 minutes. I got to go do something else. Okay, guys, any questions? Do you want to take a picture of this?
I have a quick question, Professor.
Please go.
When we're doing the join of the derived table already from
Join of what?
this ABC in red, that outline, the one we did last, not the T1, the other one. Yes, this one. When we were doing from right to left, right?
Yeah,
So
this is left to right.
no, this is left to right, and we wrote down whatever didn't match, right? On the first line.
Okay. No, you have to look at the parentheses, Sarah. Here's a parenthesis, black, blue.
Right.
Okay, so that's in the parentheses. Let's say if I say here, 3 minus, in parentheses, 5 plus 2 minus 10. So I will do the parentheses first.
Okay. All right, I get that. What I'm asking is that when you did it from both ways, from left to right and then from right to left, right?
Because I had parentheses first. First, I had a red parenthesis between T1 and T2, and no parentheses around the rest. And then I have no parentheses around T1, natural full join, and then parentheses around T2, natural full join, T3.
Okay.
That's a question of parentheses. I can write it down. I can write it down right here. So this answer is T1, T1. Actually, I can just say, I'm not going to say it. I'm going to just make it natural full outer join. Okay. I was going to do with, oh, wait a minute. First, I was doing with T2, I think. So let me go back and start the parenthesis. This is the parenthesis. Then I come back here. I have the parentheses. Now I can say natural fill outer join with P3. Okay, so for this is the answer.
Okay.
Okay.
Got
Now
it.
what is this answer for right here? Let's write it down. It is T1 natural full outer join. What I need to do is put parentheses here and say T2 natural full outer join. Don't write this. It will not execute, okay?
Okay.
Okay. So this is the answer for this. Okay. All right. And this is the answer for that. Right here. Okay.
Okay, got it. Thank you.
All right. Anybody else? Okay. Anybody wants to take a copy of it, take it. Okay. This is going to be erased. All right. I got to move on. Okay. Share the files and share this. Where the heck is that? Anybody still want to take a copy? Or everybody did it already? Okay, thank you. All right. Okay, let's see what do I have here. Come on. Where was I? We went over the create table, basic query structure, the select clause, the where clause, the from clause, the joins, natural join, renaming, string operations. I explained them already. Okay, so I'm not going to worry about that. All right. I remember told you that percentage sign will means 0 and more characters. And underscore means 1 and only 1, okay? Okay. We talked about listing in alphabetic order. You got that here. We have to say order. Oh, we went over this. I'm not going to do that. Okay. Between we talked about. Okay. This, we don't need it. Okay. All right. So union, intersect, and except. This can only happen if the schemas are the same. Okay. So if, for example, here, select course ID from section, where semester is fall and year is this. So they're talking about what courses were given in fall year 2009 and what were given in spring 2010. It's just course ID, course ID. So this is the schema here, this is the schema here, they match. So you can union them, okay? And commons will not be, given twice. Now, if you want to intersect, that means they were given in fall and in this spring, then you can do intersection. If you want to see what were given in 2009 but not given in 2010, you can use minus sign, except. Okay. All right. Don't worry about this. Oh, I have to put this also so that it's available to you. Okay, I'm going to put it on. Okay. So we can also compare with null and you can read that quickly, okay? All right. Okay. So if you have something unknown and true, just you read it, okay? I'm not going to spend time on this. What I really need to say is that there are some aggregate functions which are very, very important. Average, AVG, okay? Average value, min, MIN, max, MAX, sum, and count. And we were doing count, and I explained to you count, okay? So average is just, take the average of the salary, whatever, okay? Now, if you just wants to find out here the total number of instructors who taught a course in spring 2010, okay, what will happen is it will simply add that column, okay, instructor ID column. It will just add. But some people taught more than one course, so this will not help. So if you say count star, that's what will happen. But if I say count in parentheses distinct ID, then I will get each instructor counted only once. Okay? Look here, star, you can count everything. Distinct ID, only count one which are different. Okay? So there is really nothing to say about this average, minimum, maximum, and all that. There's no big deal. Okay? This is very, very important. I thought we were doing this. Okay. So what we are saying is we want the average instructor salary by department. So what we are doing here is we use a new clause called group by. So group by department name and then take the average salary. So this is like saying subgroups. You have the whole data about the instructor, divide that instructors up into department name, and then take the average. Okay? Now, if I want only talk about people whose salary is more than something, then I have to say having average. So what happens here is that this group by is only apply, having is only applied to groups. Okay? First make the subgroups, then apply to each group. Okay? All right. Now there is another thing here which says that I just mentioned right now. Whatever is here must be in group by. Anything which is not in group by cannot appear here unless it happens to be an aggregate something. Like this is an aggregation. Okay? And I will explain to you why it cannot be done. Okay? Okay. You can ignore the null amounts. Okay. I just showed you a subquery and I'm going to show you just this and then we can call off. Okay. So here, find courses offered in 2009 and in spring 2010. So what he's doing is we will select distinct course ID from the section where semester is equal to fall and year equal this. And then we can take course ID in this also, just like I showed you before. So that means this course was offered here and was offered in here. So this is a subclass. Select course ID from section where section is spring and year is this. So if this course was offered in fall 2009, we want to say this course was also offered here. Then we take the course ID because this is the course ID you're looking for. It should also be in here. Okay? If you want to say not, it was offered here but not offered here, then you just use the course ID not in this. Okay? This is it for today. And we will talk about some more stuff on Thursday. What I want to simply say is that you please read the announcement I sent to you and make sure you got the groups and get ready to talk to me because this is the time right now to get some time over this weekend. Then the school is going to end soon. Okay? So I hope you do what I told you to do. You will do, and then contact me over this weekend or actually Friday and let me know you have done it, and then I'll make an appointment with your group. It's going to have to be done. We're going to have to do it over the weekend or Friday. Depends when you're ready. Okay? So please be very careful with your time now. Okay? There's no time to fool around. You got to work. Remember, project is 15% of the grade. Final is 20% of the grade. And there's going to be a quiz soon, at least one more quiz, because quizzes are 20% of the grade. Yeah, somebody has a question. Please go ahead.
No, I just wanted to ask the one that we had to do the business rules and the attributes and everything, entities and attributes is due tomorrow, right? Or do we?
That's okay. You don't have to worry about it, really. I just want to push you to do it.
Okay, so no, the thing was that if we're done with it, like whatever we've come up with it as a group, can we schedule something with you so we could go over it before
Yes.
submitting?
Yes.
Okay.
You want to have a meeting tomorrow?
Yeah, sure. Cause we did go over it and we kind of made the business rules and entities and attributes, but there were like 2-3 things a little confusing in it. So I just wanted to go over it so that we could just make it a final,
Professor, is it possible you can have like some type of session?
No. This is not for a session. This is an assignment.
No, I understand. So should I just set up a separate appointment as well if I wanted to check before we hand it in?
No, you can't have a separate appointment. You have to read the announcement to have somebody. You have to have a group. Okay, there are 2 reasons for having a group. Let me tell you that's fast.
I have a group.
The first reason is that I want there's a lot of work here and you're not going to be able to do it. That's number 1. Number 2, I want to help each group and I'm going to help each person. I don't have the time because I got other classes. I'm all booked already. So I will not meet with anybody unless you have groups. Okay, Sarah, send me an email and then I'll set up the time.
All right.
You too, Joseph. Make sure, let me know what is the time you cannot meet. Because I have a class also. So let me know what time you cannot meet, and then I'll meet you, okay?
All right, I'll send you the timings and then you can pick with whatever suits you best.
Yeah. And also make sure you send me what you have done and put under the name of both of you.
Yes, I have already put both of our names in the document.
Yeah. Everybody has, both of you have to have the name on it.
All right, sounds good. Thank you so much.
There's a lot of material which we most likely going to miss. We can't cover it. We have to have transactions. I don't know what's going to happen.